In today's presentation, we're going to take you through the new project to move to the other side of the reserve at Mandalong Mine. So if we just click to the next. So interesting photo on the opening slide for a coal mine presentation, but it's really where we're at the mine. So what we're doing is we're taking a mine that was producing 6 million tonne per annum, extracting 5 metres on a longwall, developing it 3.4 metres to a seam that's less than 1.8 metres thick. We're going to develop it 2.5 metres, and we're going to be cutting considerable amounts of stone. So we've got to keep this business viable. So the tonnage profile for the mine reduces significantly in the early years due to approval restraints. We're moving into a section of the mine which we were going to move into at the very end when we're about to close the mine. So we've got to mine this area first. The equipment was ordered to actually cut in another section of the mine. So the equipment is a little bit taller than what it should have been for this particular application. But due to approvals, we were forced to go there. So the real things that we had to cover in bringing all this new equipment in to the operation. Human resources. So there's so many things when you go for a new fleet of longwall equipment and development equipment, and then also surface infrastructure. We had to get people with subject expert knowledge from all the key fields of the operation to have input into the technical specifications developed for the equipment. Input from the workforce, the safety check inspectors at site to make sure they had awareness of what we were doing, where we're heading. They could have their input into some of the things that we needed to include in our scope and reviews. We needed then detailed contracts, tenders put to the marketplace, reviews of those tenders with visibility to senior management and probability that we've done a proper job and there's been no bias. And then stakeholder management. When we've got the equipment coming through, we've got risk assessment involvement from the entire work teams, people with expert knowledge, and then also part of that review process are your procedures, risk assessments, and all your documentation that's associated. Complexities with that are you're operating an already existing mine. So it's different than a new project. I've been involved in 2 new mine projects, and with Mandalong first up, transitioning from Cooranbong, it was all new gear, so new procedures, new systems. When you're operating a mine and it's an operating mine you're transitioning across, you've got to be very mindful of how you transition that process. So here's an overview of the mine. As you can see there at the top, for you guys, top left-hand side of the old Cooranbong workings. Mine started in the early 80s and operated through. They were driven then probe headings of Mandalong. The Mandalong leases all the black area that you see which has been extracted. Really a dream reserve. 7.5 metres thick of coal in the centre of those longwall blocks, extracting at 5 metres. All coal drivage, very few structures. As I said, a 6 million tonne per annum operating 180 metre wide wall, 150 in the first couple of blocks. Then the new reserve is the coloured area that you saw at the back of that slide. So surface facilities, if you look at the top left, is the new Mandalong surface site. 3 brand new fans, 2 megawatts of installed power on each one. New switchyard, surface infrastructure. Then you've got the Mandalong site in the central photo, car park facility, drift entry for all your rubber tired access. And then you've got all the coal at Mandalong uniquely comes out of 2 remote sites. The top side on the right is the Cooranbong facility. It's a overflow-underflow sizing plant that supplies directly in the power station. That product goes through an overland conveyor straight into a raring. The bottom picture is the Delta drift area in the Delta site. The coal comes straight out of the mine there, is basically sized and then runs straight into the Delta power station. At the Cooranbong site, a surface haul road was established, and if we want to export product, we can actually ship that product by truck straight through to the nearest end site and export it onto the export market. So the key figures we're going to cover in this presentation today: capital investment project. Then we'll talk about the operating systems, which I think is the key to the presentation. Capital investment projects, we all know the gear in that we run, but the operating systems is real key. And to explain what we did, it's a bit unique. And then some of the learnings and challenges we've got with operating that mine, and this pulls back to that original photo of the boy in the cannon. We've headed into an area where there's no known data. You're constantly evolving with everything we do, and those plans and assumptions that we've made for the site are constantly changing. Okay, so the key equipment that we had to run with is new surface infrastructure. So the new surface site at Mandalong was established, fan site. We did a blind bore from the first phase, and then we did a raised bore on the second because of the delays that were incurred with the blind bore operation. which came in substantially late and affected ventilation quantities in the mine, where we got to really critical that we got that shaft in because we were being restricted by ventilation. The next part we had was the development equipment, a full fleet of new development equipment. We were mining 3.4 metres with ABMs, which we'll show some photos of. We ended up ordering an extra low height MB650, so we went with the Sandvik product again. Totally unique machine, totally different than what we were previously operating. New shuttle cars, feeders and load centres. We also had a new longwall equipment supply to operate down at the mining heights that we were running. And then we had mine services, so all the infrastructure and things that you've got running through the mine, but the clearances to actually allow your transport envelopes as well. Okay, so here's just a quick picture of the new Mandalong surface site. You can see there that one of the fans is still in construction. You've got 3 fans and you've got a brand new surface switchyard. All the power is capable of being supplied from that site. Okay, so the development equipment, as we can see on the coal cutting equipment, you'd call it, you've got 4 Sandvik low height continuous miners. You've got 4 Komatsu 10SC shuttle cars, 56-inch wide, 4 brand new on-track feeder breakers, 2 new longwall shearers, and I'll show photos of each of these assets, and also braking systems on the belts because we've got regenerative conveyors. So quite a unique situation where you've got your development sections running on a regen conveyor because of the tensions and the braking that's required. So here's a photo of the 2 machines. So if you see the top machine in orange is a brand new machine, quite unique in its configuration. The miner operator stands on the ground. The profile for the machine was 2.5 metres. So the 2.5 metre cutting envelope by 6 metre wide was driven by ventilation requirements. The ventilation requirements were that they needed that profile to ensure that we could ventilate adequately. So the machine's quite unique. The side ducting, so the ventilation system comes into the side of the machine, and you can see that by the white area on the outside of the apron. The ventilation, we had our doubts that the ventilation system would work. The modelling from Sandvik had shown that the ventilation system would, and when we put it to test in the field, it was quite surprising how effective this ventilation system was. It was actually better than the system on the MB650s. The MB650 machine is the one in green. So the key difference is you notice that the operators are all on a platform. With the new machine, the miner driver's on the ground. The boulder operators are on a platform. At 2.5 metres, you're in no man's land. You're just too high to actually operate off the ground, but you're just too low to operate off a platform. So it leaves you with that compromise. The head's a scroll head on the machine. At the 6 metre width, you needed the scroll head to pull the product into the centre of the machine. Okay, next one. So here's 2 photos of the original Mandalong shearer. A huge machine, just over 100 tonne, fully dressed with drums, capable of cutting at 5 metres. The new machine, basically we call it a T-Rex. It's got a large body and tiny little arms. It's only a very small shearer, about 70 tonne, fully dressed. So the longwall supports, or the longwall support system. So here's some photos from compatibility. So the compatibility, all the longwall product is manufactured by Komatsu. Compatibility with the product was done at the Komatsu Rutherford's facility. So some of the key challenges with this equipment, the 2.5 metre process requires you to taper up into both the gates. So the gate end supports are a bigger profile than your runner face. The services in across the face with your ring main and that were quite challenging. You wanted to try and hold, and we went through I think about 6 designs to do the main gate crossover, where we didn't obstruct the access to the face, but actually effectively getting the services in and being able to manage that system. And if you have a look at the central photo at the bottom, you can see the taper that runs through the face. So the centre of the face will operate at 2 metres on the initial stage with the aim of trying to get lower. Obviously you want to give yourself a buffer while you learn the system to make sure you don't end up ironbound, but then we taper up to the gates at both gate ends to come into the main and the tail. So the original Mandalong supports, here's a photo from the UK facility, and you can see they're stretched at a 5 metre reach. So a massive support, rear walkway access, and then the new support at its 1.8 metre working height. So a substantial difference between the two longwalls. For the operation, this is a massive change. The guys aren't used to this low height. longwall. They've operated large longwalls and development equipment, so all the gear is totally foreign. So the other things, capital investment mining services. So as you see in there, we've got minimal clearances. All the LHD fleet had to be modified, canopies dropped, a new fleet of PJB Mark 7 man transporters with lower clearances to make sure we could get in under the services in the new gate roads and traverse the pit. So the real key behind this presentation, the equipment's the equipment, but it's how your systems integrate with each other. So you've got your safety management system in the middle. You've got risk assessments that sit at the top. Risk assessments need to be live documents, and Phil's going to explain the process with that, but too many times we replicate risk assessments. You've got multiple risk assessments that sit there dead. We need to have one. My philosophy is we have one risk assessment for each asset type where possible. It becomes a live document. You get a legislative update, you get an alert from an OEM, you buy a different kit equipment, but it's the same process in many applications, so you're continuously reviewing that document as you add data and you update. Then you've got your isolation procedures, your safe work procedures, your management systems. All of these have got links to each other, they reference each other. One thing that's key is that if you change one link in that chain, you can blow apart your whole management system, your cross-referencing and those things, your training documents. So you have to be mindful how you attack the process of changing and updating for new equipment with an operating site. What we basically did where we could was walked off one piece of gear, kept the same procedure numbers and management system numbers, and then updated the photos and the literature within that document to make sure that all the referencing links stayed intact. And as I said, Phil will explain these processes in detail, but it's a key thing to consider. And some of the things we struggle with as you look at, just a simple transition with legislative clause numbers and the confusion that that creates. So when you do look at your systems, take that into account, and I'll hand it across to Phil and he'll run through the way that we actually attack this process from this point of view.
Thanks, Shayne. So as part of a member of the project team that was tasked with integrating the equipment to site, one of the biggest components of the project was updating and reviewing the safety management system. So over the next couple of slides, I'll just talk through some of the challenges and some of the opportunities that we saw from that process. So risk assessment's one of the initial phases of the project, and one of the challenges, as Shayne just talked about, was determining if similar equipment could live in the same risk assessment, or if we needed to separate them into separate RAs. So basically, this was a compromise. And the compromise was on if the equipment was similar enough, that there wasn't sort of a number of controls that only suited one piece of equipment and a number of controls that were sort of common. But if there was enough variance, say take the miners for instance, they're the same model of miner. One's just a low height version and one's a high seam version. There was sufficient number of changes in that. Sufficient number of changes in that equipment that meant that the controls would get really confusing and the risk assessment was hard to digest. So we took the path of separating them out, knowing full well that you end up with multiple documents that you've got to review, and then the challenge down the track becomes controlling contradicting controls if they're reviewed at different times for different reasons. One of the opportunities that we saw come out of the process, though, was the revision and updating of all the risk assessments associated with the equipment in the project. So a lot of the risk assessments dated back as far as 2006, and as an industry, we've sort of come a long way between then and now. So we were able to bring them up to the standard that we sort of practice risk management today. Just to give a bit of an appreciation for the workload that was undertaken in that part of the project, we completed over 40 risk assessments, which generated more than 1,100 actions, and the project team completed 72 change managements alone, so there was other change managements obviously in other departments as well. One of the unique risk assessments that we conducted was around remote isolation. So we hadn't really previously used this at site, but we saw there was an opportunity there given the height restraints and access and egress across the face in the longwall. So to do this, we used a slightly less traditional layout where we grouped jobs that may be carried out under remote isolation into categories based on the duration of exposure to the hazard and the ability to avoid harm. And that's similar to the logic used in functional safety. So this gave us a clear distinction between jobs that were acceptable under remote isolation and those that weren't. The next area that we began to work on was around safe work procedures and the isolation procedures. One of the key challenges here was to maintain the accurate document links, like Shayne talked about, so that we avoid a breakdown of the document network. We had to manage this differently for development than the longwall. This is because the development system was being introduced alongside an existing system, whereas the longwall asset was to be switched off at the same time as the new one was being switched on. So the longwall maintained the same document numbers and links and general document network. We only had to worry about updating the contents to relate to the new equipment. But for the development equipment, the existing high-seam MB650s still have multiple years of service at Mandalong to develop the mains roadways. But this will be occurring at the same time as the low-height miners develop the longwall blocks. So these operating systems have to work in tandem with each other for some time. So one of the key components to control potential confusion between using both operating systems at once was to ensure that there was a very clear and standardised approach to the naming conventions of the documents. To give an indication the workload that went into this part of the system, we developed more than 30 isolation procedures, over 200 safe work procedures, created more than 30 new training packages and updated a significant portion of the management plans. The level of detail that went into these documents contributed to the workload. Some of the examples on the slide show the detail within our isolation procedures, where almost every action within the 12-step isolation process is accompanied by machine-specific photos to guide each step, using that old philosophy of a photo's worth 1,000 words. Training for the new equipment was managed using a train-the-trainer type approach. We upskilled a couple of guys on each shift in each crew, and then these were the guys that took priority in going to the OEM training. These guys were then tasked with using the site-developed training packages to train their peers at site. And the workforce consultation was probably one of the most beneficial resources in delivering the project. They did a commendable effort in the risk assessments and in the action workshops to follow. One of the most successful aspects of that program, though, was the progressive trial plan. So this progressive trial plan was basically an action that came from the development process risk assessment, and the intent was to carry out each aspect of the development process work in isolation before coordinating them together as one activity. It was conducted in a low activity area of the mine and had no production targets or pressures, as it didn't really form part of the mine's business plan. So each shift was given a list of tasks to complete where they would record comments, questions or suggestions for improvement. We met with each shift on a weekly basis to log new issues and communicate back to the crews on the progress or the outcomes of previous issues they had logged. We logged and found resolutions to over 100 issues during this process. So I'll hand back to Shayne now just to go through some of the maintenance strategy, as this is an ever-evolving system as we learn more about the new domain.
Okay. So one of the key things with the maintenance strategy has been that everything that we assumed previously has changed, and we went through, I developed the original plan with the budgeting process of overhauling the equipment at 4 years, in line with the electrical overhauls. Previously at Mandalong, the overhaul program had been able to be stretched out to 6 years. Mechanical wear wasn't really an issue. So for an AFC, we'd lose about 0.6 of a mil per million tonne, and for a BSL about 1 mil per million tonne in wear. So not a very abrasive product. and even the CMs were fairly robust at the overhaul program, so the electrical code was driving that. What we had to do as we went through that process was look at the equipment, look at the wear rates and work out what was going on with the equipment. So the equipment process now, development-wise, we're going to be driven wholly and solely by a mechanical wear process. I've pulled the overhaul schedules back to a 3-year program. What we're seeing with the stone that we're driving in, it's 100 MPa plus. The abrasive index is 1.5 to 2. So the cut of barrels, for example, on the new machines, just under 2 kilometres of drivage, they're tearing out the keyway on the drive mechanism that actually gives you the head extension. Those barrels are being laser clad, remachined and then reinstalled. I've ordered a complete centre section of the machine, so the full conveyor section, apron and tail, and the thought process will be that we'll change that complete centre section of the machine out every 12 to 18 months. We're doing 3 monthly belt thickness testing to trap the wear rates that we're seeing on the machines. Some of the interesting things are that the Crucible hard facing is wearing, but the side plates and things like that, the areas that haven't got the hard facing are wearing dramatically quickly. The other things that we've got in that process are that the spares inventory is a real key. So having the gear available for your overhaul program. So the thought process with the development gear, 2 spare heads, complete conveyor section, but then another 2 sets of barrels to be cycling through workshops to try and keep up with the wear rates that we're seeing on the equipment. Longwall drums, very similar process, and then longwall overhauls. So basically what we're going to be doing is we're overhauling longwall every block. Previous budget assumptions were to go through and do 2 blocks per overhaul because the tonnage rates really weren't there. But you're looking at 700,000 to 1 million tonne of extraction, and then getting the machine in the workshop just to see what the effect of that stone has on the arms, the down drives, shoes we're expecting, and trapping shoes and skid shoes we're expecting to be totally gone by the time we finish a block at this stage. So some of the gear that I've ordered for the walls, 4 sets of drums, extra drums on top of the 4 sets that we currently carry. It's another spare ranging arm, and then, as I said, that overhaul program.
So one of the most significant business risks that we had to work through for the low height longwall was determining the operating height. So operating the longwall at its lowest design operating height would be to significantly reduce the stone being cut, and in return would bring lower operating costs, reduced equipment wear, and ultimately a saleable product with the level of ash that it contains. The compromise, though, to operating at 1.8, which is its lowest operable height, was to affect carrying out of maintenance tasks. So, for instance, a leg cylinder couldn't be changed at less than 2 metres, restricting access and egress across the face, and a risk of equipment damage due to low clearances such as that between the tow arm and the underside of the canopies, which I think stands at like 28 mil or something, so it's pretty tight. Moving forward, one of the challenges for Mandalong will be cowl management. So Mandalong haven't operated a shearer with cows on it before, and whilst they're controlled via the automation on this system, they're absolutely critical to the loading function of the drums. So without the cows, they basically have no loading ability whatsoever. And this is sort of due to the shallow vein depth, which is a product of the hub size that we needed to transfer the power, and the height clearance that we were constrained by. Another operational challenge that becomes a factor in relation to the cowls and the cut height compromise is the clearance to rotate the cowls. So we need at least 1.9 metres clearance to rotate them over the drum. And while this is okay for the arm and the gate end, the arm facing the centre of the face at the time won't be in the ramp up section of the face. So basically that will have to come into play if they're considering operating at 1.8 in the future. The change in roadway design has also had significant effects to hung services. So some of the controls we put in place to manage these risks were a height indicator bar, similar to what you see at a shopping centre car park, on the roadways into these panels. modifications to the installation services, standards of the service installations, and modifications to the mobile machines, such as what Shayne spoke of earlier. Issues are always going to be identified on machines, even with the most comprehensive purchase specifications. Sorry. It's the job of our systems at site to capture residual risks before they become an issue, and pleasingly this time they did this. So it's not one particular system that picked up on all the gaps, but rather using them all collectively. So for example, the need to pin the feeder to the floor to prevent movement due to belt tensions from the regen conveyors was identified in the risk assessment for that machine. The clash point between the feeder, tow point and the shuttle car boom raise cylinder was picked up during the introduction to site, and the clash point between the feeder hungry boards and the shuttle car conveyor motor was identified in the progressive trial plan that we talked about earlier. So following on from that last slide, there's a picture of the new feeder breaker boot ends that we have. They arrived to site with a tramming clearance of 170 mil roughly, and basically it just got hung up everywhere we tried to tram it. So we worked with the OEM and fitted some raised blocks at the central pivot point and got ourselves an extra 250 odd mil. And so to show how far-reaching this change to Mandalong has been, I'll just briefly touch on some of the service projects that we undertook as well. So the stone dust line used to travel from the main gate through the pan line into the tailgate, and to achieve the design of a longwall with a 1.8 metre cut height, we had to reduce the spill tray height. So what we did was we now deliver stone dust via the tailgate roadway to the outlet site in the tailgate, and this is done using existing systems, but just a modification to those. The existing emulsion reticulation system on your right of the screen was installed originally using 1000 kPa rated poly, and with the topography of the new mining domain, where the top of the longwall block is in some scenarios up to 94 metres higher than the mains, it led to us needing a reticulation network with a higher rated capacity so that we could use the head pressure to get us up to the top of the longwall blocks at the required flow rates. So we've replaced that whole reticulation network.
Okay, so some of the key things, and as you can see, no matter what you do with your technical specifications, it'll all be something that comes from right field. And when you do the compatibility trials between one asset to another, is where you pick up these things that Phil just covered in that presentation. And they're things that sometimes get missed. You know, the seam rolls with the feeder breaker, the seam's very undulating, and obviously the feeder was spec'd to a certain height profile, but just the ground clearance for the front of the hopper was something we needed to rectify. And working with the OEM, we were able to do that, but it was picked up at those initial trials. With the longwall operating at the height it is, we can't operate that wall with people on the face. So it's a full remote operation of that wall. So what we did, the spec for the wall is a fully automated Komatsu wall with the latest technology that Komatsu has available. The previous longwall block, before we got off the full height wall, we actually operated that fully remote. So we tested the system and tested the progress of the development of the applications with software, and obviously our ability to manage that operation from the surface to give us the confidence that we needed to actually go into the new longwall with some prior knowledge and familiarity with the system for our new operators. So the picture you've got on the screen is on the left-hand side is basically a picture of when we're operating the existing Mandalong wall from the surface. And then the picture above the text is the new longwall ops room that will be housing the remote operation hub for the longwall system. So as we commission this longwall system, we're going to have 5 engineers from Komatsu out, Ashira, AFC, product line experts and programmers that will be checking and commissioning that automation technology as we go through. So key learnings, as I said, you've got to be adaptive with everything. We talked a little bit about the overhaul programs, but there's a lot of stuff that hits you from right field and you just need to adapt to, and it's part and parcel of working in every operation. So not only have the overhaul programs changed, but simple things. so your cutting consumables. If you look at the second picture in, you see the picture of a brand new pick, and then you see a pick that's substantially thinned out next to it. It's what we call penciling. We've never seen it before at Mandalong because we cut predominantly coal. So as the pick's rotating in the holder, what's happening is the side of that pick with the abrasiveness of the product is washing away. What happens from that process, if you look at the next photo along, the back of the pick actually wears away, so you can see the loss of thickness on the bottom side of the pick. And you also see an indentation in the insert, which is the far picture, where the pick's actually ground itself down into the insert. So effectively you can lose up to about 10 mil of effective approach on that pick. What happens as well, when you get that penciling effect, the insert starts to wash away on the sides. The issue you've got with that point is then the insert washes and then your pick block starts to wash, and then you lose the structural strength of that whole application, and you've got to get a drum out to get repaired. I had a look at some drums from Aquila. Aquila cut considerable amounts of stone up in Queensland, and they actually do a few things where they carbon impregnate the insert, and they also laser clad the insert face on the taper. So what we had to do with this system, our pick change-out procedure talked about, missing inserts, missing tips and things like that, but it never covered penciling. So we had to include that in our pick change-out procedure. We had to educate the workforce on that particular phenomenon and when to change that out. Insert wear was never an issue to us as well, so that's another new thing where we're changing out considerable amounts of inserts. We've got inserts and picks away with 3 companies at the moment doing metallurgical analysis, so we've got the OEM involved, but we've got 2 external companies doing metallurgical analysis on the picks and the inserts to see if there's any manufacturing deficiencies that we could use to improve the life of the product. Usually when you go to stone, you go to a shorter pick. We've had some learnings with Sandvik, and we've actually gone to a longer pick, an 89mm gauge pick, which gave us a more effective cutout. What you need to do is have your tool breaking the product away and not grinding the product away. So you've got to get your sumping speeds correct and your cutting rotational speeds correct to be able to achieve that. And what happens, the very first photo, once you get that grinding effect and you lose your dimensional tolerance with your pick wearing down in the insert, if you put a brand new tool in and the 2 neighbours are worn, it'll just tear the tip straight out of the brand new pick because it takes too much load in that initial bite when it hits 100 MPa stone. So last of it all, what I'd like to do, this is a photo, we had an open day at Komatsu in the mini build. We had all the Centennial senior management and Komatsu senior management up there to go through, and then we actually invited the department, something that we used to do all the time, but we invited the department to come up and have a look and run through the mini build, which was a good day and an opportunity for everyone to just have some familiarity with the new gear and see it on the surface. I'd like to thank the people in the room, Mikio, Phil Hyde, Simon, for the support and that through this project. It's been a big project, it's been a number of years. We're still in the middle of it. The longwall's due to kick away on the 27th of this month. So it's not finished yet, but we're learning a lot as we go, constantly adapting to the changing mine conditions. You've got to keep the operation viable. So if you don't adapt, then everyone's livelihood that works at that operation is affected. So you really need to be mindful and think of all those people that rely on our mine as a part of their livelihoods to try and make sure we keep this a viable operation. And we can do. We just need to change the way that we currently operate. So thank you.